Alright guys, today we are going to be covering some other functionality of R. Specifically, we're going to be looking into the creation of functions, a little bit of data manipulation, and hopefully the introduction of a t-test, which is one of the other parts that we suggested to include in our syllabus. Alright, if you remember functions, we covered this earlier in our introduction to Visual Basic, are these very complicated processes that you have to repeat over and over and over again. So you don't want to be, every time that you want to make a calculation, redo the whole process. Visual Basic allows you to include the entire process into a single function, so that all what you have to do is to type the function, enter the data that you want to run through that process, and the function will give you the result. So the same thing that you did in a Visual Basic, we're gonna do it now in R. So I'm assuming that you are already located in R. Let's just do quickly here demonstration. So let's just create, for instance, a variable that is called A, and that variable has a number of 1. And let's create another variable that is called B, and that variable has a number of 3. And let's enter just another one that is C, and that is equal to 3, right? So let's imagine that I want to sum A plus B plus C, right? The value is 6, right? So obviously you can do more complicated stuff. You can do exactly the same summation. By the way, for you to go to take the same code that you just wrote, you can just push the key arrows, the up and down arrows, and that will move you up or down into the lines that you just wrote. So we just want to go back to this line. We want to take all of that summation, and we're going to divide it by 100, right? Then we want to take the same value, but we want to calculate the log scale of that. So log of that value, right? Let's imagine that now we want to calculate the exponential of that, right? So you type there, right? And you just get the picture of different mathematical calculations that you can enter there. Obviously, the calculations can be more complicated than that. So the idea of a function is that you just enter this one value, these 3 values, 1, 2, and 3, and the function will do all of these calculations and will just give you this one value here. So just let's find out how can you get a function in R, right? So my suggestion is go to the internet, open a new window there, and just click there, how to make a function in R. Again, keep in mind that one of the things that I would like to do on this class is not so much for you to learn what I'm teaching you, but also for you to learn how to do things on your own, right? So which is the reason why I want you to learn how to find out the necessary information for you to do this on your own. All right, so let's do this quick search here, how to make a function in R. So you get a lot of different web pages there. And here's, for instance, one pretty neat, how to create a function in R. Let's just see what it does. You can just screen over that. Here we found this web page. This is the first time, by the way, that I see here. So usually I don't really take a lot of time reading this, but obviously you just need to spend more time on this. Today I'm usually getting pretty good at reading over the code, but now that I scroll down, I can see, for instance, this thing here, and it just gives you a name, which is the name of the variable, something that is called a function. That function, the things between brackets, are the variables that you are going to enter, right? Now, the process that you are going to run in that function is separated by these curly brackets. So what this function does, it calculates first a variable that is called the percent, round, just rounding up the number, x, which is the value that you enter, multiply that by 100, you round that to 1 digit. And you get the results, which is pretty much paste, which is just joining the percent, which is the variable that you created, plus this percentage sign. The separation is simply a quotation there. All right, let's just run this equation quickly. Let's just generate that function in R. So the function, we're gonna call it calculate percent, right? It's gonna be equal. By the way, in R, equal is usually described with these two signs there, but you can also type equal. So right now, the adopted standard in R for you to name variables and put equals is with this sign here, right? So calculate percent is gonna be a function, right? So we're gonna name a function there. It's gonna require one variable. We're gonna call that variable X. We can call it A or B or whatever name you wanna put on it, right? So in the tutorial on the internet is X. We close it, then we open the curly brackets. Keep in mind the curly brackets are the code that is gonna be run by that function. So let's go back there. So the first thing is percent, right? And percent is gonna be equal to round X. We multiply by 100, and we are gonna round that to a digit, to one digit. Close that between brackets, and we can close brackets. Sorry, I made a mistake here. Alright, so I don't think this is liking it for me to type the function directly. So we are just gonna, for now, open a Word document so we can paste the function there. Just copy the text that I just wrote there so I don't have to do this again. So basically, the problem that I'm having here is the fact that in in R, every line had to be run simultaneously. So in this case, the function has multiple lines, so R doesn't really like that. So what it means is that you need to develop the code outside R so that you can potentially get different lines simultaneously in R. R is very unlikely that it's gonna let you have multiple lines of code being part of the same function there. All right, let's just go back here. So I have my function here. The first thing that I do, again, in that function is to calculate a function that is called percent. That percent is gonna be equal to round X, which is the value that I enter, multiply by 100, I digit to 1, and then I'm gonna enter another variable that is called result, and that's gonna be equal to paste, which again is just merging the different strings, a test with a number with a number. I'm gonna paste percent, and to the number, which is the number that I calculated here, this variable percent, I'm gonna attach the percent sign. So, and the separation is just an empty space, right? Then this function, I want it to return to me the result value, right? So you can just copy this, paste it now in R. So there seems to be an error here. Oh, it's the way in which I type function there. So it's function. Okay, very good that I found that mistake. One of the first things, whenever you encounter those problems, R is pretty good at telling you where the errors are, right? So when you saw I copy and pasted this function here, the error is in the first line. So obviously there is something wrong in this first line. So you look at it, obviously the problem here is that I misspelled the word function. So Excel obviously doesn't recognize that. So I just corrected that here on the test file. So I copy that again. and now I run that function in R. So R now has a function that is called %, right? So on the function % just takes a number that you enter, it rounds that number, so it multiplies that number by 100 and it rounds it to 1 digit, and once that's calculated, then you add the % sign to that number, and that's the result that you get after you type that function %. All right, so let's just confirm this. So I'm gonna type the calculate %. I'm gonna open my brackets and I'm gonna put so the variable that is required is x, so I'm just gonna make x2. I click enter, and then I get 200%. Right? Again, if you look at what the calculate % is doing, is basically taking that number that you enter here, multiply by 100, round it to 1 digit, and then it adds the % signs. So again, if you enter 2, multiply by 100, round it to 1, you get 200, add this % sign, and that's what the percentage calculate % function return to you. And obviously you can create your own functions, and of course they're gonna get a lot more complicated. We're talking about 1, 2, 3 pages of code that you can run on a single line of code. Again, the importance of these functions down the road is the fact that very quickly you will see that code gets very big, right? So, and you want to be able to find out where the errors are. So it's good to always try to cluster your data into functions, so that if there is an error in your code, you don't have to go through 40 pages of code. You just need to find out what the function, what is the function that is giving you the problem, and that of course allows you to spot easier where the potential errors could be. All right, so that's how a function is done. So before we move on forward, I wanna show to you a program that is called ThinR. I recommend you to download that. Just go to the internet again and type ThinR. There you have it. And you can download it from a couple different web pages. I mean, I installed mine many years ago, but here you can, for instance, see it. You can download it from there, but there are several other pages where you can download this stuff from. And basically, it is this program here. And this is the program that I commonly use to keep my code. Again, a lot of people probably have recommended to you to use RStudio. RStudio is a great development. It obviously had become very good. They had improved it quite a lot. Unfortunately, I already lost that boat, and I prefer to use to run my code directly directly in R. And I like to keep my codes always organized on this program. All right, so let's go back to our function. Again, we had you scroll back up. We wanted to do a function that does all of this kind of stuff. The exponent of log of a plus b and c, right? So again, if we want to replicate that as a function, we can call it do weird things. That's gonna be the name of our function. That's gonna be equal to function again. We're gonna enter 3 variables, a, b, and c, right? So what do we want to do? So you open the curly brackets. So we want first calculate the sum, where you're gonna generate a variable that is called the sum, and that's gonna be a plus b plus c, right? Now what do we want to do next? We want to do a division, right? So we call it a variable division. That's going to be equal to sum, to the variable sum that we created above, and we're going to divide that by b, right? Now let's do something else here. Let's calculate the logarithmic of that. So we are going to call it log, and that's going to be equal to the log of the thing that we just calculated, which is going to be called division. Let's just call it there. We're going to return then log, and we close our function. Right, let's summarize quickly this function that we just created there. Again, this could be a lot longer, probably obviously a more complicated process. So we have here a function that is called do weird things. That is going to be an Excel function. You can see R, this program, thin-R, allows you to see variables that are already, functions that are already in R. So for instance, when you get this red or blue coloring, that means that those are already functions from R. Okay, so what do we have here? Again, we have a function that is called do weird things. It's a function. It's going to require three variables, A, B, and C. The first thing that it does is to calculate a variable called sum, which is equal to the summation of A plus B plus C. Then there is another function, another variable, that is called diff, and that is equal to the sum variable that we created just above, this one here, and we are going to divide it by B. Then we're going to calculate another variable that is called log, and that is equal to the log of the variable that we just calculated. And once all of that is done, I want my function to return to me the log variable that we just calculated. So let's run this. I hope that you can see already that there is an error on that function. So okay, so we run this. So we noted an error here on this line. So take a moment to think what could be the error there, right? R sometimes actually gives you some hints into where the error is. So here it tells you there is an error and there is an unexpected bracket, right? So you look at our function, obviously the error that we had there is that we didn't close that bracket there, right? So we had the opening bracket, but the closing bracket, but we don't have an opening bracket there. So let's fix that error. Let's go back to our thin-R. We close that bracket. Now we copy the function, and we're going to run the function again in R. So the function is done, right? So now R has a function that is called do weird things. Now let's run that function. So we type do weird things. As I told you, as you saw, it requires three variables, A, B, and C. So A is going to be equal to 1, B equal to 2, and C is equal to 3. Then I click enter. Now, it's an error here, right? It says error in your function. And basically what it tells you is it couldn't find the function return, right? So I did that on purpose. So just for you to see how to debug some of these problems. So really, obviously my problem there is that I misspelled that the return in the result, right? So I go back to thin-R, and now I correct that spelling mistake there. Now, as soon as I corrected that spelling mistake, you see how now that word turns red. That pretty much tells you that there's a function that is already in R. So I copy that function, and now I paste that in R. Now again, let's test our function that is called do weird things, and it has three variables, 1, 2, and 3. I click enter, and then I get my value there. So again, it's the way in which functions are run in developed in R. Obviously, you can do a lot more complicated stuff in there. Now, what I want to do a tutorial today with some practical applications, and we're going to be trying to do some, again, creation of some functions, some data manipulation, and hopefully some statistics. Let's see how far we can go today. So for that, I'm going to give you two databases. I will email them to you later. They're on my hard drive here on the F drive. They are here under presentations, methods, class 3. So I'm gonna send to you these two files, right? And basically what they are is just the heat waves that are there in the world today in 1950, and the ones that will be there in the year 2099 from the IPCC report. So these are just a couple of files that that we are working on in another project. So I figured that we could potentially just use these two files today as an example. Let's just open one of them for us to see the structure of this database. So as you can see, my phone is already start getting big there. So when you open that file, this is what you get. Again, we had the cell ID. That is, right now we have the entire planet divided in cells of 1 by 1 degree. So this is the cell ID. This is the number, the heat anomaly. This is the humidity. This is the percent excess humidity. This is how far from the normality, from the average humidity that heat wave was. Again, if we select that row there. So this is a heat anomaly that happened on this cell. This is the cell, that's the first heat anomaly of the year 1950. This is the humidity during that heat anomaly. We had, this is temperature, these are the winds, this is called solar radiation, days to the summer. This is here the start of the heat wave. So that heat wave, it starts in January 11 of 1950 and it stopped in January 11 of 1950. So this heat anomaly was only 1 day long. You can see here in the duration. Now if we look at this other heat anomaly here, this heat anomaly started on November 19. Sorry, hello? Yes, I am in a presentation right now. Can we talk in an hour? What is this about? Oh my God, what happened? Okay, we are on our way. Okay, bye-bye. Okay guys, sorry, I got an emergency with my daughter. I need to find out what this is about. I will continue the second tutorial in a little bit.